So here you have a problem. X is a continuous random variable with probability density function. So you need to find k and expected value of x and variance of x. So it is similar to the previous problem. Do the same work, same kind of work. You'll get the answer. Okay. So next. So let's look at one more problem. So here is a question. So a discrete random variable can take all possible integer values from 1 to k, each with probability 1 by k. So find its mean and the variance. So what do? So let x be a random variable. And it is saying it is taking all possible integer values starting from 1 to k, and the possible values of x are 1, 2, 3 and so on up to k. Okay, and if you look at the probability of each with the probability 1 by k. So there are k quantities, so probability that x is equal to I, and this is always equal to 1 by k, and this is true for every I which belongs to 1, 2, 3 and so on up to k. Means everyone has a weightage of 1 by k, that's what it says, each with the probability 1 by k. Okay, so you know what is a probability mass function, and you know what are the values this random variable takes, and can you find its mean? So mean, that's equal to, we denote with nu, that's equal to expected value of x and you know that is summation I is equal to 1 to k. So this is I into p of I, or probability that x is equal to I, however you write. Yeah, so this is summation I equal to 1 to k. So this is I into 1 by k. Okay, so 1 by k is a constant, so I can take it out. 1 by k into summation I equal to 1 to k I. Can you see what it means? So this is what actually 1 by k into, so what I have here is 1 plus 2 plus 3 plus and so on plus k. So now what is the formula for sum of the first k integers? I hope you know the formula. So formula for this is nothing but k into k plus 1 by 2. So you can cancel k and k. So this was exactly k1 plus 1 by 2. So this is the mean of the distribution, k plus 1 by 2. Okay, so next they are asking for variance. So what is the variance of this random variable? Let's see. You know the formula for variance of x, which is actually expected value of x square minus expected value of x whole square. You know what is expected value of x, so it is enough to calculate expected value of x square. Let us try to do that. So as per the formula, this is summation I equal to 1 to k. So now this is I square into probability that x is equal to I, isn't it? So now this is summation I equal to 1 to k. So this is I square. We know probability that x equal to I is 1 by k. So similarly here you can take 1 by k common. So this is summation I equal to 1 to k. So this is I square. Now what is this? So this is exactly representing sum of the squares of the first n integers. or in other words you can write it like this, 1 by k, and this you can write it as 1 square plus 2 square plus 3 square plus and so on up to k square. And I hope you know the formula for this guy. So this is 1 by k into, so this is k into k plus 1 into, what is the formula? 2k. Can you tell me what is the formula for sum of the squares of first n integers?
K into k plus 1 into k plus 2 by 6.
K plus
2 by 6, sir.
Are you sure?
No, sir.
Tell me if you are sure. That's not correct. I've written half of the formula. K into 2k, k plus 1 into. So just 2k plus 1 whole divided by 6. That's it. Okay. So now you can cancel k and k. So now you're left with k plus 1 into 2k plus 1 by 6. So this is what actually expected value of x square. But we would like to see what is the variance. So let's see. So now the variance of x, which is actually expected value of x square minus expected value of x whole square. You know this is k plus 1 into 2k plus 1 by 6, whereas here minus what I have is k plus 1 by 2 whole square. I hope from both of these you can take k plus 1 by 2 common. So therefore variance of x is equal to, the moment you take k plus 1 by 2 common, then here I am left with 2k plus 1 by 3 minus here I am left with k plus 1 by 2. Okay, so you can take LCM. So LCM is going to be 6, and here you need to multiply with 2, so this will become 4k plus 2 minus, here you need to multiply with 3, so 3k minus 3. So if you simplify, this is k plus 1 into, so this will become k minus 1 by 12. Therefore, variance of the given random variable is nothing but k square minus 1 by 12. So this is the variance, and if you look at the expected value, that is mean, so expected value of x is k plus 1 by 2. This is what. Now you can actually take them as formulas. For example, suppose if I give you probability distribution like this, x and p of x, let's say I am saying it is taking the values 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me take it up to 9. So now each of it having probability 1 by 9. So this is a random variable with equally likely outcomes. Okay, a sample space with equally likely outcomes, a random variable which is having all likely outcomes. Let me see. So now here, can you tell me what is the expected value of x for this problem? What is the expected value of x? I hope you have the formula on the board.
Yes, sir.
Yeah, that is 5. Why? Because here k equal to 9. So this is 9 plus 1 by 2, that is 5. Whereas if you want to see what is the variance of x, yeah, so this is 9 square minus 1 by 12. So that's going to be 81 minus 1, so that is 80 by 12. Okay. So this is how you can simply answer. You can take help of this result. Right. So remember one thing, if it start from 0, you have to be careful. Okay, if you start from 0, I cannot go up to 9. I can stop with just up to 8 if you want 1 by 9. Okay, so now you make use of the previous result to answer this question. So now my next question is, I have x and p of x here. So now this is 0, 1, 2, 3 up to 8, and each one is having the chance of getting is 9, 1 by 9. Can you tell me what is the expected value of x here? This time be careful, it is not starting with 1, it is actually starting with 0. Now what you have to do is, you try to construct a bridge between these two problems. It is actually starting from 1, that is starting from 0. So you do one thing, you try to define a function y which connects this one and the previous problem. So what I'll do is, I'll take y equal to, see here itself I'll do one thing, instead of writing x and p of x, let me write y and p of y. Okay, so now if you see the relation between the previous random variable and this random variable, you could see that y is exactly equal to x minus 1. You see, when x is 1, it is taking the value 0. When x is 2, it is taking 1. When x is 9, it is taking 8. 9 minus 1. So there is no change in the probabilities. They will be remain the same. So now it is enough to calculate, if you want to know what is expected value of y, so that's what expected value of x minus 1. So that's what expected value of x minus 1. So you know what is expected value of x, that's actually k plus 1 by 2 minus 1. So that's what k plus 1 minus 2 by 2, that's what exactly k minus 1 by 2. Is it okay? So if you start from 0 and if you go up to k minus 1, this is what you must understand. 0, 1, 2 up to, you're going till k minus 1, and the chance of getting each is 1 by k. So in that case, the expected value is k minus 1 by 2. Similarly, you can think about the variance of x. So when you look at the variance of y, that's what actually variance of x minus 1. But we know the formula for variance of ax plus b. I hope we have done earlier. Yeah, so here is the property of variance. Variance of ax plus b equal to a square into variance of x, right? So now using this property, I can write this guy as variance of x, that is 1 square into variance of x, that's it. So this is same as the previous result, that is k square minus 1 by 12. So there is no change in the variance, but whereas there is a change in the mean. Is that clear?
Yes, sir.